Okay, let's hope that you can see what's currently going on my screen. Here I will pull up my referee logic. Here you can see I used IEEE standard logic. I included it all. You can see me declaring all of my inputs and my one output, which is the final call. And if we just go into the architecture, which is properly formatted, I might add, the way that the logic essentially works, and I presume everyone did it like this because it's data flow. When it comes, if head ref and anyone else says yes, or if head ref and anyone else says no, then it automatically has to go to them. Because even if head ref and ref one both say yes, if ref two and ref three say no, well, head ref breaks the tie, so it's gonna be yes, and that goes for both yeses and nos. And really, the only way that head ref gets overruled here is if all three of the other referees agree, which in that instance, head ref's decision does not even matter because it's already a majority rule. And we can actually see here, if we come over here, I made a component. I brought all of those variables in. Well, I'm sorry, not variables, signals. Got to remember, VHDL, not programming. We're writing to hardware, except for this first lab. Here you can see my signals. And down here is where we go through, well, I did the proper assigning map as well because it did not like it when I tried to just do it back to back to back, ref 1, comma, ref 2, comma, ref 3. It did not enjoy that, so I directly assigned them. And here we can see that I was going through all of the options. You can see me count. Essentially, if you look here, you see me counting in binary with these three, while head ref stays constantly at 0. And I do this for the first 8 possible options because I count 0 through 7. And then at that point, that's where they will override head ref. And that's all the options where head ref will say no to the call. And then here come the next 8 options where the head ref says yes to the call. It's literally just a truth table, as I'm sure you can put together. And here you see me essentially use ref 1, ref 2, and ref 3 to count in binary yet again. When I waited for 20 nanoseconds simply because that's the way you did it in the lab. If you prefer me to pick my own time, let me know. I didn't really put too much of a comment here because these are all the exact same little snippet of code, just with a different number, which one's high, which one's low. That's why I just said it goes through all possible referee options, of which there are 16. Then that simply ends the process. And if I come over here to run simulation, I get to see how long this actually takes now. Because every time I ran this before, I watched YouTube. And there we go. Now, if we return all the way to time 0, and we zoom out a little bit, okay, a good bit. There we go. Look at that. Beautiful. This is the outcome of all of our effort. We can see here when all 3 say yes and head ref says no, they tell head ref that his opinion does not matter because it doesn't. We got all the options where head ref breaks the tie, makes it happen, and we've got it here where head ref's the only person that says yes, nothing really happens. So yeah, it's very apparent here that head ref is a very big determining factor in whether or not there is a yes or a no. Now, I do believe that this is the correct map and what it should look like. This is what makes logical sense in my mind, because as far as I know, again, head ref breaks ties. If head ref and ref 1 say yes and ref 2 and ref 3 say no, then because of head ref, it's going to be a yes. That's how I interpreted the lab. Um, and vice versa if head ref and ref 1 say no. But yeah, this is the extent of what I did for this lab. If there's anything that I'm missing or anything that I should do better or improve upon in lab 2, please let me know. Thank you. All right, let's go back to here and stop recording.